Welcome to our presentation. In the next few minutes, we will share with you some of the field-tested ideas to fine-tune your DC facility. Remember to turn the sound on your PC on. This presentation will describe our profiling and slotting techniques. Every facility is different. What works in one facility will not necessarily work in another. Usually, when you have failed to conduct true profiling studies and maintain proper slotting discipline, we see some combination of these 8 symptoms. Let us take the first 3 symptoms. 1. Cluttered inbound docks. There's no room available to put away the products received. The dock is full and there are orders waiting for some of these items just received today. So we offer these items for picking without putting them into slots and incrementing the inventory balance. I am sure you have never done this in your facility. 2. Trailers waiting in the yard with critical inbound merchandise. 3. Pretty soon you have symptom 3, an overflow rental warehouse about a mile from the main DC. These 8 conditions are symptoms, but the real culprit is bad layout and bad picking process, etc. Given all the variabilities, how do you profile a given facility? Our process is methodical. We focus on 3 measures first: the ABC analysis, lines per order, customer analysis, and many local facility layout product requirements. Yes, we all believe in the 80-20 rule, that 80% of the movement is created by only 20% of the products. But check this, in many cases, like order fulfillment centers, it could be 95-5. Or in grocery facilities, it could be 60 or 80-60, meaning 80% movement is created by 60% of the products. We first create a 1-inch accurate storage layout of the facility. The red color lines seen in the dock and between storage racks are the travel grid paths. We load the current product information over the layout. Show the ABC codes. Red is for A items, blue for B, and yellow for C. It's quite common to see mostly yellow or C items everywhere. We make it easy to see the activity level at each and every slot. We define hits as the number of items or number of times we visit a slot. Using our proprietary 3D techniques, you can see all the elevations better, and you can walk through the aisles and through the cross aisles, etc. We use a concept called penalty costs. All the slot move recommendations must be prioritized by the net savings we create. You can say that the penalty costs is an indication of how much money is lost every day due to the items being slotted in the wrong slots. The out-of-kilter index is a measure of what percent of the items are in the wrong slots. We simulate the order picking function using recent order picking data from the facility. We simulate twice, before the slot moves and after the slot moves. We convert the savings in distance traveled to hours to dollars using actual wage rates, and we subtract the cost of physically implementing the moves. This net amount is stated as the penalty costs. You will see here the video showing how we create and run the order picking simulation.
All our simulations use the XYZ path coordinates worked out. We define both speeds and capacities for forklifts. Forklift operations may have different work schedules. Include staff and work shift details. Staff may be assigned to different sections of the facility. They may have different work shifts. Insert accurate work standards for manual pick. Define both labor and space costs to compute penalty costs. Product placement groups. These groups define what types of products can be slotted in what sections of the facility. Based on the placement group criteria, we first indicate which items are occupying the wrong slot. We run the slot move routine to highlight the high-value moves. We graphically show the various slot moves. We now run the two simulations, before the move and after the move. This identifies the penalty cost associated with the suggested move. Penalty cost. This screen shows that today's moves are worth $8,000 to the facility.
Who is your customer? Are there more than one customer type? What types of items are ordered? How often and in what quantities? Our detailed order profiling methods explore these questions. In many facilities, particularly in the food service sectors, we have clearly different customer types, serviced with same generic product but in different containers. For example, the tomato ketchup is packed differently for restaurants versus grocery chains. How many lines are ordered? Lines per order helps determine the picking methodology. Pieces per order helps to determine what type of cart, tote, pallet to use in picking. Based on the lines per order, this graphics shows different picking schemes like consolidated pick, velocity-based slotting, family-based slotting. Typically, in a large facility, an order may consist of picking in many zones or sub-buildings, and they may end in the packaging area. We have coined the term bad orders and good orders. We define a bad order as the one that takes the order through many aisles, and a good order takes us through just a handful of aisles and then goes straight to the packaging section. We have developed some unique techniques to slot items in such a way we try to reduce the number of bad orders. We know that we could never entirely eliminate these bad orders. If the system uses a pick to belt or a hanging conveyor, the difficulties compound when good orders get stuck behind bad orders. How do we slot the warehouse in such a way that a large percentage of the orders are picked complete and take a detour straight to the packaging area? Otherwise, productivity gains in picking is lost as the order gets stuck on its way to the packaging station. Do you want a design that optimizes based on today's variables and yields the lowest cost design for today? Or, having reached an optimum solution, we relax a few key variables and provide a degree of flexibility? A flexible design will definitely cost 5 to 10% more, but will accommodate some variability. Based on the total inventory for an item and the picking quantity, we recommend different types of storage. We use this chart as a guideline, knowing that there are always exceptions. Most products have some degree of crushability. Weight is the most obvious criteria, but the material of the container, tin, plastic, glass, corrugate, and the shape of the container also plays a key role in crushability. In some situations, we can use the carton height as a second or third sort level to build sturdy pallets. Keep heavier items on the bottom, keep bulky but lighter items on top. The next few screens describe the type of data we need. We will need a CAD or equivalent drawing showing your present layout. We will also need detailed elevation values. In our model, we need to put slot numbers for every slot, its level, and the face. We can accept a drawing with that information. We will ask you to explain the subfields in the slot number. We normally transform your number to our internal standard format: zone, aisle, bay, level, face. We ask for 3 databases. The first one is the item master. Order file refers to the pick level data for a period of 1 week. Current inventory or on hand is a current snapshot of the inventory present in all slots, both primary and reserves. This slide shows some of the speeds, time values for both forklift and order picking staff. Our profiling and slotting techniques will improve your usage of the existing space. We can definitely delay your capital expansions by 1 to 2 years. And conversely, if you have a rental storage facility that is about 10 to 15% of the size of your main warehouse, we can eliminate the need for that outside warehouse. We can slot your products to reduce damage during transit, and using case height can reduce the air packed in your outbound pallets. Our profiling will match the existing pallet rack openings with what the products demand. Better slotting will reduce the amount of travel time. Many warehouses attached to manufacturing facilities tend to be large, and often they use bulk storage concepts. By using our efficient heuristics, we can reduce the total demand by space. Installing a weekly slotting service and a labor tracking program is a win-win situation. Together, you could improve your productivity by 40+%. These projects need both parties. We bring tools, the facility staff brings intimate knowledge of the facility operations. We appreciate your time and interest in our proven techniques.